In this example, we're going to look at the chain rule as applied to taking the derivative of d over dt of ln of 2t plus e to the t. And I'm going to do it in three different ways, and I'll explain that in a second. Before I do that, let me point out that you do need the chain rule here. It's not possible to split up this natural log using properties of natural log or something like that. So it's just a normal kind of inside and outside function kind of problem. So the three ways I'll use are the z notation, where we use another variable, usually called z, at least in this book, fill the box notation, and in your head notation. And I'll explain each of those as we get to it. Okay, so for the z notation, I'll remind you how the chain rule looks. dy over dt equals dy over dz times dz over dt. And just remember that those fractions are just a different way of saying the words take the derivative of. So you could read this as take the derivative of y using a formula of t, and that equals take the derivative of y using a formula of z times take the derivative of z using a formula of t. What formulas do we start with in this case? Well, we start with a given function, y equals ln of 2t plus e to the t. Now we have to make up what the variable z is. It's not part of the original problem. It's the way that we use a variable to break the complicated formula ln of 2t plus e to the t. We break it up into two simpler ones. And typically, if you can identify part of the function as being inside of another, then z is the inside. So in this case, z equals 2t plus e to the t. And if you use that, you can write the function y in a simpler way. Y equals ln of z. Now notice you could combine those two formulas and you would just get back to what you started with, ln of 2t plus e to the t. But that's not what we're trying to do. We're trying to use those formulas to take derivatives. So let's start with the formula ln of z and take the derivative of that. So the derivative of ln is 1 over, and so this would be 1 over z. Okay, now let's look at the other formula, 2t plus e to the t, and take the derivative of that. And so 2t, the derivative becomes 2, and e to the t, the derivative is still just e to the t. And so dz over dt equals 2 plus e to the t. And what the chain rule says is that we should simply multiply those two formulas together for the derivative. So 1 over z times 2 plus e to the t. And that's true as far as it goes, but this isn't the right way to write the answer. We should get rid of z because we are the ones who kind of put z into the problem as a way to help us, but it's not really part of the original formula. So we should replace it. It's still equal to the same thing it was when we first introduced it. It's equal to 2t plus e to the t, so we replace it, and our final answer is 1 over 2t plus e to the t times 2 plus e to the t. Okay, so now let's look at a different kind of notation. I call this the fill the box notation. And the basic idea is that I take a look at a usual rule for a derivative, and instead of writing it with x, I write it with a box, and then the box starts empty, but we can imagine putting something inside of it. So the usual rule for the derivative of ln is 1 over x, but if I write it with a box, then it would look like 1 over the box times box prime. And so then we would imagine putting something inside of those boxes, the same thing inside. Okay, so that's the rule for ln, the chain rule version of ln. So let's now apply it to this function. And let me make the boxes a little bit bigger so that we have room to put a more complicated formula in there. So that's the way it looks. And now you could just take that formula and you could write it on a piece of paper and you could fill those boxes with 2t plus e to the t. And again, each box gets the same thing. So this says the derivative of ln of 2t plus e to the t is equal to 1 over 2t plus e to the t times 2t plus e to the t prime. And that last prime means that we aren't done yet. We still need to take that last derivative and then we'll be done. But as long as you have that prime there, you haven't taken it yet. So I'm just going to write one more line, and I will also get rid of the boxes. So this is 1 over 2t plus e to the t times 2 plus e to the t. Okay, I'm going to do it one more time, and this time I will use what I call in-your-head notation, and that's kind of a silly name. What I really mean is that you say certain words to yourself as you're looking at the right part of the formula, and the words are describing the step you should do. So the words are derivative of the outside, don't change the inside, and then multiply by the derivative of the inside. And I will color code these steps so that I can show you the part of the formula that they apply to. So derivative of the outside will be red, don't change the inside will be blue, and multiply by the derivative of the inside will be green. Okay, so starting with the original formula, d over dt of ln of 2t plus e to the t. In other words, this is saying take the derivative of ln of 2t plus e to the t. Let's start by identifying the outside and the inside, and I'll do that with colors. So ln is in red, along with the parentheses, and then 2t plus e to the t is in blue. So I should take the derivative of the part in red. And ln, when you take the derivative, becomes 1 over. So I will write that in red. 1 over. Then we should not change the inside. It was clear on the left that the inside is 2t plus e to the t. It's perhaps a little less clear on the right-hand side, but I'm still going to write it in blue, and I know where it needs to go. It needs to go underneath that 1 over. So that's what I mean by the inside when I have a fraction, is the part on the bottom. Okay, and then the last part is and then multiply by the derivative of the inside. I haven't done that yet, but it will go on the far right-hand side of that formula. So I will write it in green times 2t plus e to the t prime, and again the prime means that I haven't done that derivative yet. So I'll just have one more step where I take that derivative, and at that moment I won't write the prime anymore. So 1 over 2t plus e to the t times 2 plus e to the t. And that's the end of the example.